All right, well, good morning, everyone. My name's Quinn Bailey. I work with OpenMake software. Yeah, my name is not Tracy Reagan. I'm standing in for Tracy Reagan. So today I'd like to talk a little bit about how we at OpenMake software use Perl in our DevOps, dynamic DevOps solution. I subtitled this, How to Hack Your Way to a Comprehensive Build and Deploy Solution. So before we get, well, DevOps is you know, a buzzword, a hot word right now, and maybe it's overplayed, overhyped. And really from, wow, that is getting distorted. Really from our perspective, this is a new old thing, right? This is a common problem that's been going on for a long time, the disconnect between development and operations. And while with web technologies, web applications, there are new challenges with that. These are a lot of the old challenges and old problems that have been around, you know, through various systems, various types of applications for eons and eons. So I like to say, you know, DevOps is in some sense kind of a no-brainer sort of idea, and basically the idea of left hand meet the right hand, right? These two parts of the organization need to be coordinated in order to work effectively, although the regular state of things is pretty dysfunctional in a lot of organizations. So just to give you some background as to what who we are, you know, what OpenMake software is. We've been at this quite a while. Really, our primary focus or our roots, where we come from, is in build management. So, you know, it's a little bit different when we take on web applications, languages that aren't compiled, which seem to be fast, such as Perl, but at any rate, build management is really where our roots are at, and managing the creation of and deployment of applications from source control. We've been at this probably, the company's been around for about 17 years, so it's, as I said, we've sort of been at this a while. So, and I think, you know, while DevOps is kind of a hot buzzword that maybe even you know, makes some people a little ill to to hear it over and over, especially you know, when companies are using it trying to sell you something. But the basic idea is really nothing new. You know, in other disciplines other than software development, you know, the idea of systems engineering, a unified discipline, someone who oversees, well, maybe not someone, but part of the organization, a part of the process that oversees, you know, taking newly developed products and guiding their move into production, is not really a new idea. And just to give you a little bit about our philosophy behind this, you know, my sense of it is you know, you want people with I forgot the term that I was going to use. You want generalists in this role people with a broad knowledge of what goes on during development and the sort of challenges that are faced when newly developed products go into production. And this person isn't really a superhero, isn't really necessarily even the brightest developer, the brightest technical mind at an organization, but really just a pragmatic problem solver. And I think just as important as being a pragmatic problem solver, people in this role need access to resources to actually fix things when things go wrong. So DevOps is, buzzword du jour, and it's not a silver bullet, but neither are any of the other good practice, good practices in software engineering aren't necessarily. None of them are silver bullet. Just like Agile and Scrum, but people who understand and buy into the basic philosophy and incorporate it well into their organization, it will give you results if you work at it. So. I think one important thing about this is, to some people, DevOps, there might actually be a methodology or even a tool set prescribed for that. We like to think that we have a great tool set for it, but really, I don't think of it as DevOps is really a methodology or prescription for any particular one way of doing things, and it's as I said, maybe a bit overhyped, but it's it's one of those things. It's what folks are talking about, what we see people talking about in our market, and we feel that we've got something to say, something to add to that conversation. So the basic idea of having as far as what a tool set might enable an organization to do, I think of these three as big the major points that you want to hit with a DevOps tool set. So it should allow for enhanced collaboration between developers and operations. The actual business of building, packaging, deploying, configuring an application, you should never do more work than you need to. So maximize reuse of those. If it's going to be, if you do have scripts, well, you pretty much have to have scripts, but organize them in a way that you can maximize the reuse of them, and then as the process is moving along, provide as much insight as to what's going into a release. What's everything, is there a single place we can go to find everything we need to know about this release or this individual component? So what, for example, results from any automated tests, just general logging of the build or package or configuration process, and any sort of additional reporting, such as maybe dependency analysis, or since we work a lot with financial and insurance companies, having reporting for audit capabilities, for audit requirements is also very important from our perspective. So I'll try to minimize the marketing mumbo jumbo, but as I know, technical folks don't care too much for that. But the basic idea of having a dynamic DevOps suite from our perspective is to enable continuous integration, continuous deployment, and make this a regular habit. Build, deploy, configure early, to real environments. Maybe not necessarily, well, production for sure, but obviously starting with a test or QA environment, and do that early and often. Failures are going to happen. That's why we practice this and make deployment to production by doing this often. Make that a lower risk event, so that when failures happen, you're prepared to fix it, to redeploy, and have that not be a big disaster. So, as part of this, what our suite allows for is dynamic build automation and acceleration, and then also dynamic package and deploy automation, and then also provisioning of machines in either a private or a public cloud. That's the general idea. So basically, we want we want speed, we want consistency, control of the process, insight into what's going on at any given point in the process, so that there can be straightforward handoff between the software development teams and IT operations, and that the definition of these processes are standardized and centralized in some fashion, so that at any given point a person can look at the definition of a given deployment, a given build, and see into what goes into that process. And I think now also the capability that we have, not just our company, but all of us have to use these cloud environments, these virtualized environments, gives us an opportunity to control and line up the development and production environments in such a way that you avoid this drift between the environments that can often happen when when using in the old way of doing things when using physical servers. So, okay, so as far as what we specifically do that's different, or we like to think of as different, the architecture of our system is basically for any of these build, deployment, package, configure processes. There's basically a template, a model, objects in a sense that you can instantiate to do those different tasks. What we refer to them as build and deployment services, and the instantiations we refer to as target definitions. I think that just on the words themselves should be fairly intuitive. But basically the templates are how you maximize reuse and make the system dynamic, make it able to respond to change quickly across all your applications. You know, make a change to the template, that change will then propagate throughout all the applications that use that template. And really, in our experience, you know, even large enterprises with scores of applications using different technologies and platforms, in some cases only need a handful of these templates to define their build and deploy process. So once you have these templates, the other two important ingredients are central server, the store of the templates and the various configuration, environmental and target configuration data, and then an agent on the actual machine where the build or the deploy is going to happen, and then a rules engine to process the templates to say, okay, given this input, what do I go and do? The rules engine is also pretty important because it's doing dependency analysis and scanning, and then reporting after the process is done. So, I'm sure some of you are wondering where Perl comes in. Well, for us, Perl is the glue. Perl is what we make our templates out of. And since our rules engine is written in C, and this tight relationship that Perl shares with C, that's why we chose Perl to make our templates. So Perl is the glue, or the duct tape, if you prefer. Basically, the way this works, our rules engine populates template scripts that we have, the template scripts being written in Perl, with configuration data that it reads from the central server, and then combines that with scanning that it does on the file system based on the target configuration data that you pass to it, and then what it actually populates in our Perl templates are our own custom Perl objects for managing files and paths and options, you know, usually in lists or associative arrays, and then the templates process all that data so that those Perl objects allow the templates to process the data in a way that it's you know, we can present it then to whatever actually is going to do the build, you know, the compiler, in sort of, as I said, our roots of thinking come from build management, but of course, you know, if you need to package or deploy or you know, configure properties files, This is all done in these Perl templates. So. Mm-hmm.
What's the argument for C here? How do you C and not Perl?
The argument for C,
Legacy, speed, which?
I think probably. I mean, I didn't write the system, so it's hard to say. I would say legacy in the sense that when the tool was first written, Perl was still kind of young. I mean, right? The company was started. I guess maybe I don't know my history well enough. From our perspective, the folks that developed it, back in 1995, I think Perl was still kind of young, and the architect of the system was familiar and comfortable with C. I think speed is an important part of it, although Perl does pretty good on that a lot of times. But yeah, I think legacy would be the other reason. Just that's how it was designed to begin with. But certainly the flexibility that Perl gives you, I think, makes it very appropriate choice for the templates, because, right, these tools that we have to interact with to build and package and deploy and configure, it's always in constant flux. So besides Perl being the glue, though, you can also think of it sort of besides what the rules engine does. You can think of Perl as the workhorse of the application, because it's doing most of the process execution, file I/O, and then collection and formatting of the output of these processes to pass it then to our logging and reporting daemon, which is also written in C. Let's see. Yeah, so we have to execute various processes, and read and write from files, and format this data, this output, and Perl's a natural fit for that. So from this point, there's not too much specifically about Perl at this point, right? We have to, the design of our tool is to support all manner of applications and platforms, and a lot of that is sort of typical. Maybe even, I guess the word might be legacy, C and C++ builds, and Java, and compiled applications compared to newer web apps that don't use a compiled language, that are using interpreted language. But the basic idea is we have this command center that handles sort of basic execution interaction with the remote agents. And this is the central location and the place that we define all of our integrations and templates that are used by the build system, well, DevOps system. You can see I still think of us as a build tool, even though we're fast moving into DevOps as being sort of an integrated discipline that includes a lot more than just build. Mm-hmm.
What's the implementation architecture of Mojo?
The implementation architecture. So the yeah, okay. So the server that manages all that is it's written in Java. It's a Java web app, and then the GUI. There's a web GUI that we use GWT for, so also Java, and then there's an Eclipse. There's also an Eclipse GUI because we do integrations with Eclipse, and also just have a standalone rich client that's Eclipse based. Yeah, I mean, there's only so many components, right? So the server and the remote agent are written in Java. As I said before, the rules engine and the logging and reporting daemon are written in C, and the glue that holds it together is Perl. So Mojo is just sort of, in some sense, we term it workflow engine. It's analogous to something like Hudson or Cruise Control. Just execute scripts, execute processes. So what Meister is providing is the dynamic aspect of the build process. These template scripts that the template defines how for an organization how we build a WebSphere or web service or something like that. And so that gives you control over the process, over the logic that drives the build in such a way that you can quickly respond to any changes. And given that you're taking in some cases hundreds I guess it depends, but many scripts and centralizing them into one location and reducing the number of scripts significantly, that's going to simplify the handoff between teams. Because instead of these one-off script-driven processes, you have these model-driven processes that are doing your build. And one thing that I haven't mentioned yet that I think is pretty important, because of the dependency analysis that we also do during this process, that allows us to do an incremental build, to do and to accelerate builds, because you only need to build what changed, and a similar thing happens on the deployment side, right? We can do an incremental deploy because we know what changed and what the impact of that change was. We have integrations with various Eclipse and Visual Studio to allow this process to happen inside the IDE and then easily move to an environment where that happens outside the IDE. And you don't necessarily need to use our workflow, the Mojo Command Center for driving this process. You can plug us into a tool like Hudson. So yeah, as I was just saying, because we have incremental binary management and we're managing those dependency relationships, that allows us for our Deploy Plus product to do incremental deploy and provide insight to the deploy process. So deployment is basically Deploy Plus product is a similar story to our build product. There are templates and a rules engine, and the way to do your deploys is basically to instantiate one of the templates for deployment, and because these templates and the tool interacts with the central knowledge base, we call it the knowledge base server of this information. All the information about deployments are stored in a central server location. And you have logs and reports for the deployment process. The last piece of the puzzle, and this is one that's still developing for us, is what we call the CloudBuilder part of the product. It's become apparent to us, since we've been taking this approach for some time, that using cloud or virtual images of machines to manage your environment, that's a similar sort of approach, right, to the templates for the build and deployment process. We can have spin up images in whichever environment we need to quickly, and be sure that that image that we're using is what we want to be using, and then basically spin up a cloud image. Do a build, do automated tests, do deployments to that environment, and then spin it down when it's not needed. So whereas organizations might have previously needed a handful of physical servers to handle all of this, it can be done on one server, or one physical server, and then virtual environments on that hardware. So I think there's not too much more that I think is relevant for you guys, but I don't know. Any questions at this point, I guess? Yeah.
CloudBuilder, there's a lot of people in that space. Are you
Right.
compatible with, interfacing with, or thinking about replacing what you have with one of those?
So what actually we provide is a front end and an integration to a product by CA that is that they've released recently. Well, I guess it's now been about 3 years, and they keep changing the name of it. I think they originally called it, what did they call it? Virtual automation, and then they sort of integrated it with their other tools for managing physical servers. Now they call it server automation, I think. So basically what we provide with CloudBuilder is a front end, and also integration with that, such that our data that we collect and manage can be passed on to those cloud environments. Let's see. I think that's the last slide. Yeah, any other questions at this point? Mm-hmm.
You say you integrate with build management for, traditionally for compiled languages.
Right.
But that you also support interpreted languages like Perl or Python or whatever.
Mm-hmm.
How do you manage interacting with the build process for that, or packaging that up? Do you rely on your customer to write their own script for packaging it, or is there any standard process you use?
Right. So what basically, that part of the product is still developing, and basically when we have a new customer, we work with them to help define either to define new processes for that, or reuse existing templates, right? You know, basically every customer that we work with, we gain more knowledge of different types of applications, different types of platforms, and how you build applications and deploy applications for that that language, that platform. So we provide, as part of our knowledge base, right, existing templates for doing build and deployments, for basically all the tools that we know how to work with. And if we don't know how to work with a tool or platform already, we work with the customer to define that, so that, you know, they have a standardized process, and that they're not writing one-off scripts for that process.
Do you have an example template for building Perl that you could show us? Or?
You know, to be honest, no. I think just because of the fact that you know, we haven't had a customer that uses Perl in that way. So again, this maybe it wasn't too clear from the get-go, but this talk is more about how, you know, we use Perl in our commercial product, rather than, you know, how. I mean, I would like to be able to give you guys all the answers for how to use our tool to work with Perl applications, to build and deploy them. But really, what we have is a framework that could be used, could be applied to Perl applications, but we don't yet have templates for Perl applications, though we do rely on Perl ourselves. So if there's nothing else, I think that's it for me. Hope I at least gave you guys some ideas on. I mean, I think even if you weren't to use our tool, some of the ideas that we use in the tool, you know, having templates for the process, and you know, I realize there are other tools that do similar things to this, but you know, in the history of our company, we've encountered a lot of people who do use Perl for their own homegrown custom solutions, and it seems a natural fit because of the flexibility and you know, speed and sort of low level management interaction with the OS. So yeah, besides the templates that we have written in Perl, I think the other major components are the central server, the remote agents, and some sort of rules engine. I mean, you probably could use or abuse Make or Ant or some other build tool to as a rules engine to interact with templates in this way. So. Mm-hmm. Yeah, I guess I didn't speak to that directly, but part of the whole process is naturally going to be some interaction with version control, and really the value that we add in that space, besides just going and calling a version control tool to get updates or that you might need, is because we're actually managing the process that compiles or builds or packages the application. We can interact with the version control tool to determine exactly what version of a file from version control went into a given binary, a given release of an application. So yeah, thanks for. Right. Yeah. Yeah. So the type of report that I'm referring to is what we call build audit report, and that's another. We're able to provide build audit diff reports, by comparing different runs of the same build to see what the differences were. So yeah, if something broke in version 3 that wasn't broke in version 2, you'd be able to see pretty quickly what it was, provided it's actually in source control. That's always that can be an issue, but again, that's the idea, right? The tool would expose that for you. Thanks. Yeah. Thanks for your time, and let me know if you have any other questions. But.